Welcome to lesson number 5. We're going to be looking at the unit circle again. So when we're looking at the unit circle, and I skipped the first section of this unit, or of this lesson, which is just deriving the special triangles found within the unit circle. So you can review that from pre-calc 11 notes, or in class I'll help you with just deriving these different coordinates for each of these angles that are formed around the unit circle. The really important thing to remember with the unit circle is that these are special triangles, right? So I got 30 degrees, 45 degrees, 60 degrees, and if I look at all of the other angles on the triangle, they're all reference angles of 30, 45, and 60. Now, another important thing to remember are these formulas for sine, cosine, tangent, cotangent, and all the other ones, so secant and cosecant as well. But the big ones, remember, for this are sine, cosine, and tan ratios. If you remember sine, you can remember the other ones, right? Sine, I remember this as 7 yellow rabbits. And then if I know that sine theta is equal to y divided by r, I know that cosine is going to be equal to x divided by r, and tan is just y divided by x. And then all the other ones and all the other ratios are just the inverse, or not the inverse, but the reciprocal of the other primary ratios. So in the unit circle where r is equal to 1, that's another really important thing to remember, is with the unit circle, the radius is equal to 1. And remember also that sine theta is equal to my value of y, and cosine theta is equal to x. An example is, if I look up here, if I was looking for cosine of 60 degrees, for example, I know since my unit circle, if I have my unit circle and I have the cosine of 60 degrees, that's going to be equal to 1/2 the x value of, or the coordinate, and the x value of that coordinate at that angle. And we're going to look at a few other examples here. So if we look at class example number 1, I have sine 300 degrees, and I want to use the unit circle to find the exact value of all the trig ratios for the rotation angle of 300 degrees, and give each answer with a rational denominator. Alright, so let's look at sine 300 degrees. If I'm looking at 300 degrees, I know that that's going to be in quadrant 4, and 300 degrees is right here. Now, with the sine ratio on the unit circle, the sine ratio is equal to my y coordinate, so negative √3 over 2. So when I have sine 300 degrees, that's going to be equal to negative √3 over 2. When I have cosine 300, that's equal to the x value, which, if you look again at 300 degrees in quadrant 4, that was equal to 1/2. If I'm looking for tan 300 degrees, that's just equal to sine theta over cosine theta, which is going to be equal to negative √3 over 2 divided by 1 over 2, and we can rewrite this as negative √3 over 2 times 2 over 1, or negative square root 3. If I'm looking for the cosecant 300 degrees, then remember cosecant is the reciprocal of sine 300 degrees. This would give me negative 2 over √3, but I want to have rational denominators, so I'd have to multiply that by √3, √3, which would give me negative 2 √3 over 3. And then secant is just going to be the reciprocal of this, which is 2, and my cotangent is going to be the reciprocal of this. So if I had sine theta over cosine theta, cotangent is cosine theta over sine theta, or 1/2 over negative root 3 over 2, which we could then rewrite as 1/2 times 2, negative 2 over root 3, which would be negative 2 over 2 root 3. Once I rationalize my denominator here, oh, actually a quicker way to do this is if I look at my reciprocal of negative root 3, which is just 1 over root 3. It's going to be way faster, but we'll end up with the same answer here. But if we look at the negative reciprocal, or the reciprocal of negative square root 3, I'm going to end up getting 1 over negative root 3 times root 3 over root 3, which would give me negative root 3 over 3. All right, use the unit circle to find the exact value of the following. So cosine 3 pi over 4. Now cosine 3 pi over 4. So we can do the exact same thing with our unit circle, but use radians instead. So if I'm looking for 3 pi over 4, I gotta determine in which, I need to determine in which quadrant 3 pi over 4 is going to be. So remember, if it's telling me cosine 3 pi over 4, that's referring to my angles. And so 3 pi over 4 is in quadrant 2, right here. And if I'm looking for the cosine of 3 pi over 4, that's cosine is my x value, so that's going to be negative 2 root 2. Negative 2 root 2 over 2. For all these other values, so cotangent of 5 pi over 3, again, we would just find where 5 pi over 3 is, with the angle 5 pi over 3 radians is on my unit circle, and I would use the corresponding values. And so if it's the cotangent, it becomes cosine theta over sine theta, and I would solve.